Hi, welcome to this latest video. It's for Leetcode 112 Path Sum. This is a problem that's actually not super difficult if you look at how many lines of code it takes to solve the problem, because you could solve this problem in 3 lines of code. The thing is, this problem represents a special technique that is going to be very important for coding interviews, and that technique is depth first search, or commonly referred to as DFS. Something that you're going to have to know pretty well if you want to at least get some of the first intro problems correct on these interviews. So this particular problem, we will see, requires some knowledge about, I guess, trees, right? So we'll go over really quickly. A tree is also, right? And a range of things that are trees fall into the greater range of things that are graphs. And so trees, if they're binary trees, they have 2 children at most, right? And there's usually like a root from where you start. Now, there are 2 general techniques when you want to traverse the nodes of a binary tree, and there's BFS and DFS. And so in this case, the problem is asking you to find, if we look at the problem again, is asking you to find the value from root to leaf, okay? Make that blur. So if you look, there's a root to leaf value adding up to a target, okay? So obviously you're going to want to know how to start from the root and go all the way down to the leaves. So now, if you want to think about this problem at its very basic level, you can have a tree that has 1 node, okay? And you can have a target of 8. Now, if a tree has 1 node, what happens when your code visits that node? Well, you say, well, the node value equals 1. And does that equal to the target? Because you added all the value from root to leaf. And in a single node tree, root to leaf is just the node itself, right? So does 1 equal to 8? No. So you return false. So you know that part of what you're going to need later on in the code, when you arrive at a particular node that's a leaf, okay, if you're at leaf, you are at leaf, check the value, right? And you check to see if that value, if the target, which I think they call sum, minus the value, grants you the value of 0. Okay? So that's one thing you're going to have to know. Now, obviously, they're not going to ask you to solve for the problem of a single node tree, because that's comparison of 2 numbers. So let's take a look at just a tiny bit more complex tree. 2 node tree. Now, imagine the target is 4. So what happens when you're at 1 is that you say, okay, well, do I see that my current value meets it? No, right? So then you would go check out to see if you have children. You go left, right? You go left. Now when you go left, you want to know that you already consider the value of 1, okay? So then at that point you say, well, does the value of 3 match the target minus what I had before, which is 1. So what you know is your code has to consider where you go, right? And subtract current node. That you have to do. So that's another rule. So the first rule, if you're at a leaf, remember, is you see if the current node matches the target or the sum. And then now you know that if you want to check a child node, you are checking that child node against the sum minus the current node's value. That's important to know, right? And so let's check out a slightly longer tree. All right, so now we know that you have this tree with 4 nodes, and here's the root, okay? Target is 7. And so you check the value at 1, does not match. So you go left. And you run some function, right? And you check the value against, this would be root.left, and the value would be 6 because you're checking against target, which was 7, minus the value of the current node, right? Oh, I guess this has to be 8. Sorry guys, 8 if you want to find something. So then here you check the value of 5. Well, 5 doesn't match. Depth first search, a lot of times people go left first, right? So you go left. You go left and you say, well, at this point you're calling function, you know, the node is 4, and the value at that point is going to be 1. But 1 minus 4 doesn't give you 0, so you go back up, and then you check the right node, right? And we changed this to an 8 already. Sorry about that. And you say, well, at this point you're calling the function on node number 2, and for the value of 2. Sorry, this is 2 here. And then you'll see, okay, well, at 2 minus 2, you're going to get 0. So we report, okay, we found something, right? Obviously, here, gotta change that. And I think the one thing we want to talk about really fast is that when you're doing depth first search, you need a stack. This is very important because for breadth first search, you use a queue, right? Queue is first in, first out. FIFO stack is last in, first out. Now, what is useful about using recursion? Recursion, right? Recursion is that you're using the call stack. So that's a stack, and that's a stack. So recursion actually helps you do DFS pretty easily. And so what were the 3 rules that we had? Well, the first rule was at leaf, check the sum versus minus the value, right, of the node. Right? And if you have it, you return true. Otherwise, recursion on left and on right. And that's a technique that you're going to see when you want to do DFS. There's a recursion going to the left and to the right. And sometimes you have to make a decision about what is returned from those things. And as always, for any recursion, you're going to have to need a base case. All right? So let's take a look at the code really fast. Like I said, it's only a few lines. It's something that we could easily talk about really quickly. So we note that this is DFS, okay? And actually the case number 3 we talked about was base case. If root equals null, or if the node equals null, return false. Now, the other thing we talked about was that if you're at a leaf node, right? If you're at a leaf node, and the value will currently give us a sum, then you return true. How do you know you're at a leaf node? If your left child is null and your right child is null, then you must be a leaf node. Then you check the value. You can also just return this third part as true or false if you're at a leaf node. Now, if you're not at a leaf node, that's when you do recursion, right? This is the DFS part. Now, what do you check? Well, you check your left child. And what do you check of the left child? We have to subtract your current value from sum. Now, it's very important that you use OR here because you're just checking to see if you found the value to the left or to the right. You do not need to do an AND. And that's it. That's the entire program for this problem. This is usually a kind of problem that you would get initially on a phone screen when they want to see that you actually can do an easy problem before they move on to a medium or hard problem. So this is something that you might want to kind of memorize as a utility problem, because I have gotten stuck on this in the past, and I think many average developers would as well. It's something that you just have to know that, okay, you see a tree. When you see a tree, first thing you should think of is DFS, and then BFS, and see if that works. And then you can start to think about, well, I always need a base case. I always want to check my left, always want to check my right, and I want to do something with the values, right? Right here. So I think that's pretty much it. You just have to kind of memorize this particular problem. Again, this problem is called path sum. It's Leetcode 112, technique of depth first search. After this video, we're going to cover slightly more difficult problems of DFS, and see you next time. Thank you. Bye.